Okay, we're going to look at converting between logarithms and exponential functions. So what is a logarithm? A logarithm is another way of writing an exponent. They are actually inverses of one another. So if you have logarithmic form, which is log base b, now the base b is a subscript here, of a equals x. X is the exponent in exponential form. B is the base in exponential form. And then this is what it's equal to. Now when I do logs to exponential form, I use what is called the log loop. I start at my base and I loop toward the equal sign back around to the a value. So if b is the base of the log, it's also going to be the base of my exponential function. And then loop around to the x, that's my exponent, and it equals the big number a. Okay, so if logarithmic form is log base b of a equals x, the resulting exponential form, they'll both have the same base. Whatever your logarithm equals is your exponent. And then your exponential form or your exponent is going to equal the big number next to your log base. So if you're converting from log form into exponential form, if you have a base of 3 for your logarithm, it'll also be the base of your exponential function. So loop toward the equal sign, you'll have 3 to the second power is equal to 9. So this is your logarithmic form, this is your exponential form. Looking at number 3, looping around, if this is the base of your log, it's also the base of your exponential form. So 7 to the 0 power is equal to 1. And you'll see both of these are exactly true. Log base 4 is also the base of your exponential form. So 4 to the negative 2 equals 1/16. And this is also a true equation because 4 to the negative 2 is 1 over 4 squared, which is 1/16. Now, if you're going in the other direction, going from exponential form to log form, you can use the log loop here as well. So what you would have is your log. You've got to add that yourself every time. And then just do it again, loop around. So log base 14 of 196 equals 2. Okay, once again, write down your log. Log base 12 of 12 equals 1. Log base 2 of 1/8 equals -3. So just loop around. The base of your exponent is also going to be the base of your log and vice versa. Be very careful about that and you'll be fine. Now looking on the back, it tells us the common logarithm. A logarithm with base 10 is called the common logarithm, and it can be written without the base. So if you have log base 10 of x, you can just write that without the base 10 at all. And you'll see on your calculator right here by the number 7, that's your log base 10. That's your common logarithm or common log. So use your knowledge of exponents to evaluate the logarithms without your calculator. It's very important that you don't use a calculator on these. So what you can do is, since you're looking for the answer, which is unknown, we can set it equal to x. And since we now know how to convert from log form into exponential form, I can just loop around and I'll have 7 to the x is equal to 49. From our last lesson, I know that I can change 49 into 7 to the second power. And now that I have the same base, I can set my exponents equal to one another. Looking at number 15, I've got log with no base. Well, anytime you see log with no base, it's understood to be a base 10 because that's your common logarithm. So set it equal to x, and since this is a base 10, even though you don't see it, you'll have 10 to the x is equal to 100. From our last lesson, I can change 100 into 10 to the second power. And since I have the same base, I can now set my exponents equal to one another to get x equals 2. Okay, so we're on a roll now. Let's change this to equal x, and then we're going to loop around again. So we have 2 to the x is equal to 64. I need to change them to the same base, so 2 to the x is equal to 2 to the 6th. And so I have x equals 6 as my solution. And then set this equal to x, so I'll have 9 to the x equals 1 over 81. Well, we all know that we can't have the fraction, so we're going to bring it up to the numerator, and that's going to make our positive 1 exponent a negative 1. And now we're going to make these the same base. So 9 to the x is equal to 81 is 9 to the second power. But don't forget to multiply it to the negative 1 that's already there, giving me negative 2. So my solution is x equals negative 2. All right, well, everything doesn't always work out beautifully. We know that by now in our mathematical career. So that's why we have the change of base formula. The change of base formula will take any base and change it into a base 10, our common logarithm. So if you have log base b of a, the change of base formula says that I can take the common log base 10 of a, my big number, and put it over log base 10, my common log, of the actual base, b. Now you only use the change of base formula when you cannot get common bases in your exponential functions. If you can get a common base, you better not use this change of base formula. For example, on number 21, if we set this equal to x and we do our log loop, we'll have 16 to the x equals 64. Well, it being in this section, I'm expecting that I can't solve this, but lo and behold, I can. I know that 16 is 4 to the second power times x, and then 64 is 4 to the third power. Well, that's the same base. I didn't have any trouble here. So take 2x and set it equal to 3, and we end up with x equals 3/2. So I was able to solve that without using my calculator. And if you can do so, then that's what you need to do. When we solve these on our test, I'll be looking for these equations right here. I want to see the equations. I want to see that you solve this without resorting to using a calculator. You used your brain power instead of your calculator power. But sometimes that's not going to be feasible, like number 23. We have 2 to the x equals 54. So the only base I could possibly use is base 2. But as I go through my base 2's, I'm looking for 54.
Teachers, pardon the interruption. I need all students, when the bell rings, to be sure to go by the Commons and pick up a lunch to go. Everyone go by the Commons and pick up your lunches, your virtual lunches. Thank you. Have a great weekend.
Okay, my apologies about that. But as you can see, in all of my base 2 work over here, I don't get a 54. So that means I can't change it into a common base. So I have to use the change of base formula. So the change of base formula tells me to take the common log of the big number, a, over the common log of the little number, 2. And you have to use your calculator here. You have no choice. Okay, all right, so what we're going to do is we're going to do alpha x to get our fraction bar, and we're going to use the log button. So the log of 54 over the log of 2. And you see that you get a rather lengthy decimal. So we're going to take these and we're actually going to round these to 4 decimal places. So if you go out to 4 decimal places and you look behind it, you have an 8. Your 8 will round this 8 up to a 9. So my solution will be 5 and 7,549 10 thousandths. Same thing on number 25. Okay, we can't make a common base here, so we'll do the log of the big number over the log of the little number, your base. So alpha x again, and you'll do the log of 136 over the log of 4. Going out 4 decimal places, the 3 will not round the 7 up, so you'll have 3 and 5,437 10 thousandths.